Okay, next method is MODI method or UV method. It is used to find the optimal solution for the transportation problem. So in this method, first the initial basic feasible solution of the transportation problem are found by using these three methods. One of any of the three method: northwest corner rule, least coastal method, or Vogel's method. After finding the least initial basic feasible solution, in the second phase we will optimize that initial basic feasible solution to find the optimal solution. So we will consider a transportation problem. So this is a transportation problem, and we have given the demand and supply, and this demand and supply is given. And one of the thing is, so here it is demand is here and supply, and we have to check whether it is balanced. So supply equal to demand. So here supply is 250 and the sum is 1000 and demand is also 1000. So this is a balanced transportation problem. Now we will find basic feasible solution by using initial basic feasible solution by using northwest corner rule, and we already discussed northwest corner rule, and I will find the this is the initial basic feasible solution by using northwest. So these are the allocated cells. Okay, so this is the initial basic feasible solution. So the solution is 3700, and these are the allocated cell. Now we will use this uh, solution to find optimal solution. For that, we will use UV method or MODI method by using the initial basic feasible solution is this. Now we will consider U1, U2, U3, V1, V2, V3. Okay, so we will find this. So Ui plus Vj equal to Cij. Cij is this cost value of the allocated cell. This is very important. So what are the allocated cell? This is an allocated cell. This is allocated, and these are the allocated cell. So we will use U1. Now I will put U1 equal to 0. This is initial value 0, and V1 U1 plus V1 is equal to Cij. So what is the cost here? 3. So 0 plus 3. So the value is 3. Now the next allocated cell is this. So here 0 plus V2 equal to 1. So this is 1. So next allocated cell is this. So V2 is 1 and cost is 6. So 1 plus 5. U2 is 5 and 6. Now similarly, U2 is 5 and this is an allocated cell. So V3 is 0. So similarly, we can find values by using this method. So what is that values? U1 is 0, 5, 3, V1, V2, V3, V4. And this we will only use the allocated cell. Now we will find the penalties using the formula. For the penalty, the formula is um, Pij equal to Ui plus Vj only for unallocated cell. So for unallocated cell, we will use this. So for that, okay. So this is an unallocated cell. So I will calculate this P1 first row and third column, that is equal to U1. U1 is 0. V3 is 0. 0 plus 0 minus 7. So the value is minus 7. Similarly, we will find all unallocated cell. So what are the values? So P14, the value is -5. P21 is this. The value is 5. 5 plus -1. 5 plus P21. P21 is 5 plus 3. 5 plus 3 minus 2. 5 plus 3 minus 2, that is 6. Similarly, this you can find every allocated cell. Now from these allocated penalties, you have to check whether all penalties are 0 or negative. So this is negative, 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 negative. If all penalties are less than or equal to 0, then our initial solution is optimal. Then our already got solution is optimal. But here there is positive values, so this is not an optimal solution. So for that, then we will choose the highest penalty value. So what is the highest penalty value? It is for C21. So this is the cell where highest penalty value. So we want to include this in the solution. So for that, what we have to do is, I want to put this in here. So we will draw a loop. The loop is, we will start from this newly allocated cell, this plus, and then we can move to, and there is a 90-degree turn only in the allocated cell. So we can go like here, you can 90-degree turn, and you should make it. And if it is 90, you cannot turn here or here. So that is not possible. Now we will check where it is possible. So here it starts and the loop goes. This is an allocated cell. You can 90-degree rotation, and here it is allocated cell, and 90-degree here it is allocated cell. So we completed the loop. Now after completing the loop, after completing the loop, what we will do is, uh, loop, what we will do, we will put plus or minus sign. So plus, alternative plus sign, so this as plus sign. So plus sign for the starting value, then negative, then plus, negative. So then what we will do is, we will take the negative cells. In the negative cells, there are two values, uh, 200 and 200 and 250, and we will take the minimum. Okay, the 200 and 250 minimum is 200, so this is minimum. Now what we will do is, we will subtract 200 on the cells having negative sign. So here we will subtract 200, and here we will subtract 200, and here we will add 200. For the plus sign, we will add 200. So here also we will add 200. So what you will get is, here 200 is get cancelled, 0. This is 0, this is 0, and this is 250, 200, and so on. Now we will get another solution for the problem. Now what we will do is, we will again find ui values and vj values. So for that, you put u1, v1, v2, v3, v4, u1, u2, u3, and here I'm putting 0 here, and we will find the allocated cell this, then 1, So 0 plus 1 is 1, and so on. We will find the values of, so 0, 1. Now next what we will do is 1, 5. 1 plus 5 is 6, and so on. So we will find the values of ui and vj for this, and after that we will find the penalties again. So for the unallocated cell, so this is p1 1, p1 1, 0 plus minus 3 minus 3, that is minus 6. Similarly p1 3, this is p1 3, its value is minus 7, 9, and all are negative except this. This is p32, p32. So this is the cell as negative value, positive value. Now you have to include this in the problem. So for that we will first draw a loop starting from here. This is a cell, allocated cell. You can turn 90-degree, and this is also allocated cell, and you can turn. So you get a loop. For the loop, first plus, here minus, here plus, minus. Now you find in the negative here, m- negative rows cells is this, and the 50 and 250 are the two elements, and the minimum is 50. So what we will do is we will subtract 50 from negative. So we will subtract here 50, and from here we will subtract 50. So this becomes 200, this becomes 0, and we will add 50 here. So this becomes 150, and this becomes 50. So the answer is again this is 250, 2000, and now this is a, and again, so this is a, this is the new one. Now again we will find v1, this is new solution. So again we will find u1, u2, u3, v1, v2, v3, v4. So the values are u1 equal to 0 minus 2. So, sorry, this is allocated cell 0, 1, 1. And similarly we can find. Now then we will again find the penalties. P1 1, the penalty is minus 5. P1 3, minus 6. Again minus 4, minus 1, minus, all negative. So all penalties are negative, therefore this is the optimal solution. So we can find the optimal solution by using this, that 250 into 1, 200 into 2, and 150 into 5, 50 into 3, and so on. So the optimal solution is 2450. So this is modeling method.